Hi, I'm Kate and welcome to EU TV. Positive news about COVID-19 vaccines has been coming thick and fast. I spoke to Professor Eleanor Riley, a professor of immunology and infectious disease in the School of Biological Sciences here at Edinburgh, about some of the potential vaccines and about how optimistic we should be. So the Pfizer and BioNTech vaccines, as well as the Moderna one, are new types of vaccines. Can you tell us a bit more about this?
So they're based on using the RNA, which is the genomic material of the virus, rather than using viral proteins. So with a normal vaccine, you inject either a bit of protein or a killed virus or an inactivated virus to induce the immune response. But in this case, they're using the genomic material, the RNA, and injecting that. So that goes into our muscle cells, and then those muscle cells or other cells in the muscle start to make the viral protein, which then induces the immune response.
What's the advantage in using an RNA vaccine?
So they're very quick to make. You can make very large amounts very easily, although it does turn out that they're a little bit more expensive than I thought they were going to be. They seem to be very immunogenic. They seem to induce a really strong immune response, which is a good thing.
The Oxford vaccine, which is a different sort, seems, although it's based on a small subgroup, to be more effective when a half dose is given in the first jab and then a full dose in the second than when full doses are given both times. This seems a bit counterintuitive. Do you have any idea what the reason for this could be?
So one possibility is that theirs uses a modified adenovirus to carry the genomic material to make the spike protein. And so these adenoviruses are common human viruses, and they cause upper respiratory tract infections. So one possibility is that people might have a little bit of pre-existing immunity to the adenovirus. And if you give a large dose of the adenovirus, you might trigger that immune response that kills the virus before it's able to induce the immune response to the COVID protein. So one of the possibilities is that you sneak in the adenovirus at a low dose, and that manages to evade the pre-existing adenovirus immunity. But that's entirely speculative at the moment. We really don't know whether that's what's happening. And also, it's based on quite a small number of people who received that half dose. So it's possible that as they get more data, that it may turn out that the half dose is actually not that different to the full dose. I think it's a little early to tell.
Do you think that we're getting too excited about the success that vaccines have shown in clinical trials so far? Do you think it's too early for us to be getting as enthusiastic as we are about the vaccines?
I don't think so. I think we've now had 4, if you include the Russian one, where they've all found that the vaccines induce strong immune responses that appear to protect against clinical disease. And that overall, I think, is good news. I think if we hadn't had 4 in a row, then yeah, we might say, well, one of them's a fluke and it might turn out not to be very good. But 4 in a row, all showing really very high levels of protective immunity, I think means that actually this virus is quite easy to immunize against. So I'm quite positive that they may not all work out in the long run, but I'm pretty positive that enough of them will work out that we'll be able to roll out a vaccination program.
And what are your thoughts about how long immunity will last?
So we don't know at the moment because most of these trials have only been going on for, I think the Oxford one is the earliest, started in April, so it's only 6 months. But so far, it seems that the immune responses induced by the vaccine are exactly as we would expect for a long-lasting immune response. So I think the worst case scenario is that if the immunity wanes within a year, we may have to give people an annual booster, as we currently do for flu. I think that's the worst case scenario, and I think the likelihood is that the immunity will last longer than that.
In terms of distribution, are you confident about the distribution of vaccines in the developing world, where maybe finances and options for storage don't make it as doable?
Yeah, I mean, getting vaccines out to the developing world, people who really need them in countries that don't have a good health infrastructure, is a perennial problem. It's not just a problem for this vaccine, it's a problem for all vaccines. You can look at it either way and say, yeah, it's difficult to get measles vaccine out or whatever into large parts of the world, and it's going to be hard to get this one out. I wonder, you know, thinking more positively, whether the importance of doing this, and the importance not just for the people in those countries, but for us, because we need to bring this pandemic under control globally, might just be an incentive to do things better for low and middle income countries. Maybe we should use it as an opportunity to do things better than we've done in the past.
How long does it normally take to find a vaccine for a disease, and how has this been made so much faster for the COVID-19 vaccine?
So there are a whole bunch of things that come into play there. The first thing is just how easy is it to vaccinate against this particular disease? And I think it will turn out that COVID-19 is relatively easy, but a lot of virus infections are quite easy once you put the effort in. So, you know, we didn't have a vaccine against Ebola when the Ebola outbreak hit in West Africa 5 years ago. We've got several now, and the only difference is we weren't trying very hard to make one before. And as soon as we put in a concerted effort, we found actually, yeah, Ebola is very easy to vaccinate against. And there are now several licensed vaccines for Ebola. So it's about how easy it is per se to vaccinate against that disease, and then how hard we try as a community to make a vaccine. And when both of those things, when it's easy to make and we have a concerted effort, then turns out we can do things very quickly if we want to.
Are you concerned, what with the speed of the vaccine, are you concerned about sort of dedicated anti-vaccination campaigns and more widely about vaccine hesitancy in the general population as a result of how fast the vaccines are being developed?
I think it would be easy to get overly concerned about that. I mean, I think what we know about these vaccines so far is that if you take the vaccine, you are, as far as we can tell, if you take the vaccine, you are protecting yourself against getting severely ill. And so it puts it in the hands of individuals. How worried are you about this virus? Are you worried enough to take the vaccine? I think a very large proportion of the people that we really need to take it, and those are the older population and people with underlying health issues, I think they will be highly motivated to take this vaccine because the consequence of not taking it could be very, very serious. And if there are a small percentage of the population who choose not to take it, you know, it's up to them. If we get to the stage where we find that these vaccines can block transmission and we want to try and really drive down the prevalence of the virus, then it becomes more important for a lot of people to take the vaccine. But we don't yet know that these vaccines do that. At the moment, we're rolling these vaccines out to protect the individual who takes it. And at that level, it's up to individuals. And I think plenty of people will sign up to take it, and those individuals will be protected. And I think from that, other people will gain confidence. And I think my guess is that, yes, there will be some people who will never accept vaccination, and they will take the consequences.
So just finally, what do you think we can expect in terms of getting back to some sort of pre-COVID normality in the near or kind of medium-term future?
So I think the key thing really is that the people who are highly vulnerable to getting severely ill, they need to be vaccinated. So if we can vaccinate a large proportion of those people by Easter, that combined with the fact that as the weather gets better, hopefully the virus will transmit less well, then we might look forward to a relatively normal summer. And if those vaccines really work and last long enough, then we may find that we're actually, that's it, kind of pandemic done, and we can look forward. But there'll still need to be a huge effort to get the vaccine out to everybody. But I think if we can vaccinate the people who otherwise would end up in hospital, then I think we can start to get back to normal.
Thank you so much.
Welcome.
Thanks to Professor Riley, and thank you for watching EUTV.